Hello, and welcome to Chapter 14 homework. Yeah, almost there. Almost done with all these homework videos. We only have 14 and 15. Yay! So, let's get into it, and let's hopefully have less errors by McGraw-Hill in this chapter than we had in Chapter 13. Let's go ahead and continue. And we're going to start off first. We know we're going to have a multiple regression. This is really all that this chapter was. So again, a few formulas, a lot of dealing with the software. So, Thomas PhotoWorks purchased several new highly sophisticated processing machines. The production department needed some guidance with respect to qualifications needed by an operator. Is age a factor? Okay, so we're going to have to determine, is age 1? Is a person's mechanical aptitude score important? To evaluate the factors needed to estimate performance on the new processing machines, 4 variables were selected. So we got the length of time, the mechanical aptitude, prior on-the-job rating, and age. So, here's our information. We have 2 people, and we have our 4 regressions, basically our 4 variables that we're doing. I'm stuck on regression. regression. The equation is y hat equals 10.7, which again is our y-intercept, plus all 4 of these slopes with the variables. So, what is this equation called? Just exactly what this chapter is a multiple regression. How many dependent and independent variables? We have 1 dependent and 4 independent. I like how it's like a whole multiple choice right off the bat for question 1. Alright. What is the number 0.586 called? Which is right here. This is the regression coefficient. All right. As age decreases by 1 year, how much does estimated performance on a new machine increase? Okay, so that would be our last one, the slope right there, 0.006. And you can check. Right now, it's just really asking, can you see what's going on? So, Carl Knox applied for the job at PhotoWorks. He has been in the business for 9 years. Okay. So, calculator. So he's been in the business for 9 years. So which one is in the business? Okay, that's 1. So we know 9 times 0.1. Okay, so I'm going to do them each as we go. Okay, scored a 330 on his aptitude test. Okay, so plus 0.586 times 330. Carl's prior on-the-job performance rating was 75. So plus 0.312 times 75. And then he is 63 years old. So plus 0.006 times 63. We're sitting at 218. And now we add the y-intercept plus 10.7. So we're looking at 228,758. Okay, calculate. And there we go. So really the only one in question 1 that we actually have to calculate is the last question. Yay! Last question magic. Alright, we know that was the easy one. Now here comes more fun parts. Alright, so determine the standard error of estimate. So again, using our ANOVA table, there's multiple ways of doing this. But since we're on multiple regression, we go find the formula because I like showing you the formula in. Sorry. In our good old-fashioned PowerPoint. So here's our ANOVA table. And it needs to be bigger because y'all can't see anything. Sorry. Well, so here is our table in itself. So there's one. And then here's this multiple standard error of estimate. So notice it's the square root of SSE divided by n minus k plus 1, where again k is basically the number of treatments, n is the number of observations. So or basically our regression right here, degrees of freedom. But we'll end up calculating it for us. So start. We have two ways. Again, we can use Excel or we can use the calculator. This time, I'll probably use the calculator in itself because it's just a basic formula that we got. So, calculator, where are you, calculator? There you are. We're going to take our SSE, which is 2742.06, divided by, in parentheses, 58, minus our K, 5, plus plus 1, close parentheses, equals that, and then square root. So click the square root. So we're looking at about 7.26. Right, 2 decimal places, yeah, 7.26. Maybe we really only have okay. Let's try that again. 2742.06 divided by these 56 minus, let's go 2 plus 1. And square root. .06. Okay, so we are running into some kind of fun little trouble going on here. So let's pop up Excel. Okay, so no, we need N, and we need K. So K, 5, N is 56. It's always like plus 1. Okay, and then SSE. Might be pressing it in the calculator wrong. SSE, which happens to be 274206. Okay, so the formula equals, again we're going to zoom in so I can actually see. Alright, so let's see. Or equal to square root of C divided by parentheses N minus K plus 1 7.26. Check. Okay, so there's another way. Alright, so we can also find standard error of estimates by taking the square root of 54.84. So let's do that. That comes out to 7.41. Okay, so the actual formula does not work, at least in my case. And as you saw, I actually went through. Okay, so makes it a little bit tough there. But if anything, if it's not working, take the square root of MSE, and you will actually come out to it. Crazy, I know. And then we're just on question number 2. Okay, about 95% of residuals will be available, or will be between what two values? Okay, so for us, let's see. Basically, it's taking double of our 7.41, 2 times 7.41, 14.82. Okay. So basically, it's going being between that, negative 14.92, 82, sorry, negative 14.82, and positive 14.82. Alright, check. There we go. Determine the coefficient of multiple determination. Alright, so that's just going to be our SSR divided by our SS total. Calculator, 3931.60 divided by 6673.66, and we're sitting at 0.589. There we go. All right. Next, determine the percentage variation of the independent variables. Round your answer to 1 decimal place. Well, it is 58.9. It's basically the percentage of B-1. Okay. Determine the coefficient of multiple determination adjusted for the degrees of freedom. Okay. So, for us, this is going to be fun. But basically, our R2 adjusted, again, if we look at the PowerPoint, let's go find it. Is this fun little bugaboo right here. But we can actually calculate this out. Because really all we need to do is find the denominator, which is the SS total divided by n minus 1, which is right here, 55. So basically this number right here. So again, I'm going to use Excel just to piece them together. So equals to 6673.66 divided by 55. Now the reason why, because we have the ANOVA table, that I'm not going to do the SSE divided by n minus k plus 1, because we already have the number right here. It's the 54.84. So it's going to be 54.84 on top, the numerator, divided by the one that we just created. So it ends up being 0.45196, but it's not done because it's equal to 1 minus this number. So we're looking at 0.54804. Okay, check. And there you go. And there's question 2. Nice. Okay. The following regression output was obtained from a study of architectural firms. The dependent variable is the total amount of fees in millions of dollars. Yay! There's all our numbers. Alright, write out the regression equation. Alright, so y hat It's right here, 8.657. Okay. Again, you can check as you go, but basically all it's doing is now taking this column right here and fitting it right here into the equation. You see x1, that's its slope. And yes, it's going to yell at me for the decimal places a couple of times. Then we have negative 0.318, 0.576, and negative 0.031. Again, you can check. And there's all the answers. Okay, fine and dandy. How large is the sample? How many independent variables are there? Well, sample from the ANOVA tells me 56, add 1, should be 57. Okay, number of independent variables. There is 5. 1, 2, 3, 4, 5. So I could count, or I could use the regression. It is 5. Check. We're still good. Next. At the 0.05 significant level, state the decision rule to test if all of our things equal or at least 1 is 0. So, F statistic. Y'all remember F statistic? It's like, yay, F. Alright, so let's go find F. Where's my chart? Where's my chart? Okay. We're using the 0.05. Numerator is going to be 5. And the denominator is going to be 57. Notice that I do not have 57. So, probably going to be close to 60. Yeah, right column. So we're looking at probably 2.37. There we go. Again, closest to the one that we can in our chart. Okay. Next, compute the value of the F statistic. Is 8.45. There you go. I love it when it tells you to compute and it already gives you the answer. That's basically what they're asking to see if you can notice that they already gave you the calculation when they gave you the complete ANOVA. Okay. So, with this being said, what is the decision regarding this number? Well, it is greater, so we are going to reject. Okay. Next, we know that at least one regression coefficient is not equal. Again. Alright, now, wow, this is a really long problem. Okay, so state the decision rule for each independent variable using the 0.05 significant level. Okay, so we're going to have to find our t value now. So, and we're still on the 0.05. So t, 2 degrees. Probably going to be looking at about, see, we had 57 for the N minus the treatments, 2, 3, 4, 5. So we're probably looking at 52 at 2.07. Oops, that should be the opposite. 2.07, and this should be the negative. Okay, check. There we go. So remember, we got 5 treatments. So our t value actually has to be how much we have, how many observations, minus the number of treatments, or the number of independent variables. Alright, next, we get to do the fun part. We get to compute the value of the test statistics. So if I just went, yay! Well, you're in luck. Why are we in luck? Are we really going to compute? No. No, no, no. How am I not? Well, it's up here in the chart. So let's see. We got 2.190. 2.190. X2 is negative 1.765. Highlight, Control C, see if we can just copy. Nope, will not let me. So that is negative 2.338. Okay, next is 1.778. Next is negative 1.348. Alright, again, check to make sure you transferred all the numbers correctly. If it's all green, you're good. Next, for each variable, make a decision about the hypothesis. Alright, so we're going to reject if it's less than negative 2.007 or greater than 2.007. So here, first one we're going to reject, it's greater. Next, this is not less than, so we fail to reject. Next, that is less than negative 2.007, so we'll reject. 4 is less than, so fail to reject. And then X5 is another fail to reject. So there's actually 2 that we rejected out of the 3, or out of the 5. So those 2 will probably be removed once we do more calculations. Well, that's it for question 3. Yay! Question 4. A real estate developer wishes to study the relationship between the size of a home a client will purchase in square feet and other variables. Possible independent variables include the family income, size, whether there is a senior adult parent living with the family, and the total years of education beyond high school for the husband and wife. Okay, the sample information is reported below. Nice. We're going to go ahead and download. Oh. Okay. So, develop an appropriate multiple regression equation using stepwise regression. Use Excel data analysis and enter the number of the family members first. Okay. Nice. Okay. So, again, we're going to go to data analysis. Okay, so since we're going to develop the stepwise, we're basically going to use their information. They only want us to use family members and then their income and not really worry about anything else. So these two, we're just going to remove so we don't get them confused. And I'm going to go ahead and do our data analysis. Okay, regression. So my right range is the square feet. That is correct. And we're going to go ahead and put in the sample size, because they want us to do the family size first. This one, we're actually going to tell it to go to new worksheet. Hit OK. The reason why is that we're just going to have two regressions going on. So again, this is size. And we're going to do the same thing for income. Data analysis, regression, but this time we're going to take income. Okay, there we go. Now, fill out this information. We're basically going to be taking the information from this one down here at the bottom. So the constant is 614.1176. Family size our constant, wrong one. Our constant is 938.582. That is our y-intercept. Family size is 614.1176. T-statistic, 5.288751. P-value, 0.0007. Then our S should be our standard error, which is standard was 338.5384. R squared, they actually want R squared in R squared adjusted in percentage, so 77.7 7598. And R squared adjusted was 74.9798. Okay, again, the numbers I pulled was my y-intercept, then everything right here, up to p-value, then here's our standard, and then our R squared, R adjusted. Again, so for our income, we're going to do the same thing. Our intercept is 848.8722. Okay. Alright, so since we're doing it stepwise, we couldn't really put them separate because we're adding on to the family size. So, in our Excel, I have multiple sheets for some reason. We're going to go ahead and put the next step, since we're only at 2 on here. So we want to go to data, data analysis, and we're still going to do regression. Now, our Y is still square feet, but since I'm adding on income, we need to go ahead and highlight income and size. Okay? Notice that I do now have the labels with me this time. So make sure you click labels so it knows. Then hit OK. Alright, so it's going to produce this one. Now with 2, our income and size. So now we have completely different information for income. But we're going to be focusing on size. So now my y-intercept is 474.7694. Family size has now changed. It is now 390. So 390.0221. T statistic for the family, 3.47, 3299. P-value is 0.01036. Income. Now we work on the income line. So this line right here is 13.1922. T-stat is 2.954724. And again, I'm typing in the whole number so that McGraw-Hill can round for me. That's fine. Alright, standard error. Still these 3. Okay, standard error is 241. 241.4255. R squared is percentage 90.10 90.103, and our square adjusted is 87.276. Okay, fun stuff going on. It takes a little bit to get to the multiple regression, but we're gonna hit check and notice that they're all green. Yay! Makes life a little bit easier. Now, select all the independent variables that should be in the final model. We only did income and family size. The rest do not get checked. Here they are. write out the regression equation. Okay, so square feet should be 474.769. Family size is going to be 390.022, and income is 13.191. Notice that does take off from the final form. That's number 2. And you can hit check. There you go. Okay, report and interpret the adjusted R squared. There's really no interpreting, but we do know about 87% is covered. Basically, atones for most of the information. So, that is it for question 4. Now let's hit question 5. Halfway there. Yes. Alright, so in a multiple regression analysis, it took a lot longer on 4, but in our multiple regression analysis, k equals 5, n equals 23, which is basically 5 minus 2, that's, or 22. That leaves us with 17. There we go. The MSE value is 15.14. Okay. And the SS total is 437.09. At the 0.05 significant level, can we conclude that any of the regression coefficients are not equal to 0? Alright. Make sure we put in the numbers correct. We did. We are going to have to find F statistic. Okay, that's fine. So, a little bit more algebra going on, but not too terribly bad. First off, error. If we divided 2 to get 15.14, we naturally will times. So, calculator, 15.14 times 17, 257.38. Okay, then we know regression minus error equals total, or them add together equals total, so we're going to just subtract 2. So 437.09 minus 257.38 was 179.71. Divide by 5. 35.942. That just leaves us with the F statistic, which F statistic is just these two divided by each other. So, calculator, 35.94 divided by 15.14 gives us 2.37. It was 8.27. So it is 2.37. Okay, check. And there we go. There's the ANOVA. A lot less algebra that was in chapter 13. Alright. To test if all the regression coefficients are 0, the null and alternative hypotheses are, so forth and so on. And we need to go find our F critical value. So, off to our tables. So, tables are back. Yay. And we already know degrees of freedom was 5 and 17. So, 5 again. Now find 17. So it should be right here, 2.81. 2.81. We are correct. Rock on. Compute the F value. You already did. It's 2.37. I love it when they tell us to compute when we got a ANOVA table. Okay. What is your decision? Is this greater than 2.81? 2.37 is not. So we are not going to reject that null. Sorry. So every regression of coefficient is not significantly different. So I actually have in my random where I do not reject. Most likely you're going to reject, but who knows? Okay, so again, make sure you follow the rules. If you have to reject, then put in the correct interpretation, where at least one regression coefficient is significantly different than 0. Okay, halfway there. Question 6. We're gonna have some fun. Okay, so I just had to preview that. As we know, the questions do get harder as we go. Okay, so let's go ahead and click our independent data, or our data. Okay, enable editing. We'll mess with that later. Alright. Does there appear to be a linear relationship between the screen size and the price? There does appear to be. So the correlation of the screen and price is, well, let's go calculate that out. Not using the chart. Let's go find my Excel. Here, let's see if we can go ahead and do it the classic way. Our regression model. So our dependent value should be the price independent. Actually, probably going to be the opposite. Actually, so correlation equals square root of r squared. So probably 0.9. Wow. 0.96. Yeah. So there's a good correlation. Okay. Which variable is the dependent one? So, of course, price has to be, because that will vary on the screen size. We all know this when we go shopping at Walmart or any other electronic store. The bigger the screen size, the more it costs. And it also depends on the maker. Alright, use statistical software to determine the regression equation. That's what I already did. And here it is. So there's our y-intercept, and there's our variable, our slope. So let me put those in. And 3 decimal places. Screen size is 62.628. Okay, again, check. We're good. Interpret the value of the slope in the regression equation. So for each increase of 1 inch size, the screen size price increases by 62.628. Check. Again, it's always about the slope. Alright, include the two qualitative variables, Sony and Sharp, as dummy variables in the multiple regression analysis. Note, if both Sony and Sharp are equal to 0, then the manufacturer is Samsung. If Sony equals 1 and Sharp equals 0, then the manufacturer is Sony. If Sony equals 0 and Sharp equals 1, then the manufacturer is Sharp. Okay. So, let's go ahead and throw this in. Alright, so I'm going to actually probably put this on new worksheet. So let's go ahead and go data, data analysis, regression. Okay, so Y is going to stay the same, still the price. Now our X, actually we're going to go ahead and put this as 1. So we can go ahead and add the labels, since we're going to have multiple different ones. We'll put in the information, add labels, and OK. Alright, so it does change a little bit. So our intercept now seems to have to be negative 1713.52. Screen is 63.8488. Sony 189.888. And Sharp. See if I put them in right. We did. That tells you a lot right there. So, notice that if it's a Sony, our model shows that it increases by almost $190. Yeah. Alright. So test each of the individual coefficients to see if they are significant. Okay. So first off, we have our t-stats. So again, taken from the chart, 3.5975. P-value is 0.000, because that is like 3.1 E negative 11. So I don't think it's going to end up having very much to us. 19.9095. 0.000. Okay, Sony is 3.602, and it looks like 0.0019. Sharp has 1.53467, and its p-value is 0.14135. Check. Okay, there's all of our info. Alright. Next, it wants us to plot out the lines. Alright, so let's see. Excel. Let's go right here. And we want to go insert. Huh. So when we look at the plots themselves, this one, it's really just us putting things down. We will not have a good correlation. So it's really just calculating everything out. So if we calculate 1, how many ones we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yeah, they just went ahead and put the information in. So really, this one, probably we can just select which ones they are, because we're not actually getting the graphs to show up. So we know it's going to be a negative. The mean itself probably will not be. So this one, let's see which one. And it's actually 1. So it is a negative mean. Standard deviation is 299.7. Again, if we actually went through all the fun of calculating. Again, scatter plot, if you actually drew all, to being 1 as well. So the graphs I'm not too concerned about. It's really getting the numbers in. Okay, question 7. Let's see, another chart. Okay. Develop a correlation matrix. Are any variables that are related? Okay. Now we're doing a correlation matrix. So, starting off first, of course, we know we're going to have to get the data. and basically find the correlation between the two. So, data. Download. Enable editing. Okay, here we go. So, data analysis, regression. So, food, income. Correlations are squared equals that. Oh, square root. So 0.3519. Okay. We basically gotta do them for all. So again, we'll do another data. Okay, our food is okay. We're gonna have to change income to size. Hit okay. Equals the square root of r squared. 0.648. 0.648. Okay, next do it for the income. So data analysis, regression. Now our income becomes the y. Hit OK. This equals .3.1. Okay, check. Ah, my income's a little off. Okay, let's fix that one. So let's see. Let's try it the other way. Nope, still comes out to the same. So, see if I got a little bit of a rounding issue. Huh. Yeah, looks like I got another error that popped up in my system. Yay! I thought we were going to get clean. But nope, we got actual error. So this is an error. So if you're popping up this error, please let me know. Alright, So, there is no multicollinearity. Okay. So we are good there. Alright. Form the regression analysis. Complete the ANOVA table. Leave no blanks. Be certain to enter 0 whenever required. Round SS, MS, and 4S places to F2. Okay. So, multiple regression. So we're going to be looking at leave food. And we're going to base it on the other two. So let's go ahead and do our regression. Get rid of that sheet. We're going to go ahead and take ours. We're going to go data analysis, regression. I'm going to say our dependent variable is food. Oh, won't allow that. So food. Our X is going to be those. We do have labels. Okay. So, let's see, degrees of freedom, 2. Our error has to be 22. And we're looking at 24. And again, basically it's a copy of the ANOVA. 13.61019. SS 9.15716 0.41623 then 22.7591. Let's see if I put that in correctly. We did. Again, it's just a multiple regression. Remember, family, food is our Y. Income and size are our X's. Alright, complete the table given below. Coefficients. So now we're doing this table and we're inserting it into Connect. So return a question. Coefficient is 2.68478. Income 0.01101. And size 0.38733. SE 0.41213. 0.00354. 0.0661. And again, I'm just going to let it round itself. So I know I'm putting in all the numbers per the Excel. Okay, for p-value, we know if we have any of these crazy E's, that means there's like 6 zeros, 5 zeros before we even get to our first number. So 0.005 and then 0.00. Check. We are correct. Okay. Next, determine the regression equation. Well, that's going to be 2.685, since that is our y-intercept, 0.011 for our income slope, and 0.387 for our size. There we go. what is the value of r squared? Again, using our chart, 0.59765, so only 3.598. So mostly right now, it's just really the question is trying to get you to look at the chart and try to understand how the regression has happened. So F statistic, critical value, 222. We are at 0.05. So now we need our book. 0.05. We're at 2. And we have to go find 22. So we're sitting at 3.44. Yep. So 3.44. Check. Make sure we pulled the right statistic. We did. That's our critical value. And then, are we going to reject or not? Well, according to our NOVA, it is 16.34 is our F. It is indeed greater, so we are going to reject. So at least one of the coefficients is not 0. Okay. Next, would you consider deleting either of the independent variables? We're going to probably consider deleting one. We're probably going to delete the income, but why? Okay, so again, if I wanted to compute T statistic, we could. So T is going to be our size, which is 25 minus how many we got? 2. So basically 22. So, or not 22, but 23. So from there, if we want to do our T statistic at 0.05, whoop, MBT. But really, we're going to reject that income. Mostly, as you can see, it's pretty much the different one. Especially when it comes to p-value, it's more significant to remove. It's not really part of these two. As you can definitely see, there's a very low correlation between income and size. So we're going to go ahead and remove the income. It just doesn't favor us at all. So we're going to consider removing income. And then it wants us to do the table again. So again, I would end up doing the NOVA. So calculator, or not calculator, Excel. And one of these was just about the family and the size. Definitely not these two. So this one should be family and size. Looking at our matrix, yeah. So we already have it done. we just went ahead and removed income. So again, I'll be inputting the same info. So we input our ANOVA, 1, 23, 24, SS, 9.56827, 13.1908, 22.7591, 9.56827, 0.57351, 16.6836, 0.00. So, next, we're going to put in the table, which again, for our chart, is this one down here. So, intercept 3.65, 64, size 0.36294. Standard 0.31591, 0.08886, T-stat 11.5745, 0.0856, P-value and 0.00046. Okay, check. Make sure we put in all the numbers. Apparently I put the p-value wrong in that one. So return. Which that p-value is correct. Because it is one of those fancy E's. So, looks like we have a slight error. That's fine. Again, if that's happening to you, please send me a screenshot with your Excel. Alright. Which is kind of odd that it's not 0.000. I don't know why mine's popping up as an error, but like I said, if it does, then you're okay. So, state true or false. This is true. So, no more barrel curve. There we go. I finally remember the word. So, choose the right option of the following graph. It looks like there is no homosacredity. Alright. How much does an additional family member add to the amount spent on food? So, if we add a size to our slope, it will add 0.3629. Then actually put 0. Oh, let's see. 3629. Huh. They're going all the way from. So we figure out to remove that one, and they decide, nope, that's not going to be right. We're going to go all the way back up to the top for B. So instead of removing the income and doing the right one, they decide we're going to go up here. And this is all in hundreds. Seems like. So, 387. Yeah, so watch out for this one. Make sure you don't use this chart, which again, I don't know why that's marking wrong when it's correct. Again, that's just errors in the software. But use this one up here for your size. Okay. Feels like this has been endless. Alright, question 8. Alright. So, the director of special events for Sun City believed that the amount of money spent on fireworks displays for 4th of July was predictive of attendance at the fall festival held in October. She gathered the following data to test her suspicions. So, compute and report the regression equation that predicts fall festival activities with the amount spent on 4th of July fireworks. Okay, so let's click here for the Excel data, see if they actually combine. Yay! Only 2 items. So, let's do our data. Data analysis, regression, our Y range, and our X range, independent variable. I'll tell it to do it right here. Alright, so here's our regression. Hey, so again, blow it up a little bit. Here's our intercept, and here's our 4th of July. So our intercept would be 3.98653, and our slope is 0.5231. Report the coefficient of determination. Seems like 8 gave us a little bit easier time. 0.26247. Let's see if it's in percentage. It is. So 26, 25. 26.25. Check. We are correct. Okay. Interpret the regression coefficient. For every dollar increase in the amount spent on fireworks for July, the amount spent at the fall festival. It's a festival. Okay, so each time it is going to increase. Let's see, this is in thousands. So, by 523.10. Or, okay, so Let's see if I input in correctly. It's all about inputs. Yeah, they want it the other way. 0.5231. So again, that's just your slope. So there's a 3. Plot the residual versus the amount spent on July. Does the plot support the assumptions of regression analysis? Now we can plot it, but we know it's going to support. There. 8 is great right now. That was a lot easier and wasn't really a multiple regression. It's just a simple one. But we'll take it. 9. 9 wants to punish us for making 8 so easy. Okay, so 9. The North Value Real Estate Data reports the information on homes on the market, using the selling price of the home as the dependent variable, and determine the regression equation using the size of the house, number of bedrooms, days on the market, and number of bathrooms as independent variables. Develop the correlation matrix. Okay. So this is going to be a little bit fun. It's going to take a little bit. Okay. Enable editing. Alright. So we know the drill. We're going to do our data analysis. We're going to do regression. And for each one, price, bedrooms, those are going to be our 2 items. So price and bedrooms. Okay. Okay, so here's price and bedrooms. We're going to have it equal, again, the square root of r squared, 0.845. 0.845. Check. And no, we have done it wrong. Alright. Okay, so y'all know that sometimes we just end up fixing everything and we look through. Well, I found out how to make the matrix. So we're only going to use, well, I hate when it does that. We're actually going to use only the data that we need. So we're going to do the regression equation using the size of the house, bedrooms, days on the market, and number of bedrooms as independent. Oh, number of bathrooms, sorry. So all this, we're going to go ahead and delete out. We don't need it. We just need the days. And the rest we don't need. Okay. So, in order to do a correlation matrix, y'all like going, man, I wish he didn't like the previous one. but since we're doing a lot, we're going to go ahead and do it. So data analysis, make sure you select correlation, hit OK. Then we're going to highlight all of our data. Make sure it says group by pretty much columns. And then make sure this is checked. Labels in the first row. Okay. I'm actually going to put my equation right here. Click OK. Huh. I did have it just right. Oh. For some reason, it highlighted everything, which is odd. So. Now hit OK. Oh. I don't know why we got the regression stuff here. We're probably going to be using that later. Did not know that was there when I deleted stuff. Oh well. It's okay. We can always re-download and do this. So, but notice that did do the correlation for us. So now, all we have to do is put it in to these items. So, price and bedrooms, which is this one. So 0.841. Okay. Size 0.949. Again, we can check, and it's still showing wrong. When that is actually calculated exactly right. Let me see if I got the wrong one. Alright. I'll remove the mortgage type because that really doesn't affect us any. I'm just going to leave everything as it is as we do the correlation. So, data analysis, correlation. Alright. We're going to go ahead and just select everything because it doesn't really change anything. We're going to do new worksheet, hit OK. Nope, we come out with the same one. For bedrooms. So, it looks like, again, we have a bad one. So, let's return the question. Now I'm going to go ahead and fill out the whole chart. Let's see if any of them are correct. So size bedrooms. Baths. For the price, 0.794601. Bedrooms. 0.970472, and then size is 0.836283. Days on the market, bedrooms, size, and baths. That's our negative. negative 0.00501. Alright, let's see if any of them show up correct. We do have a few correct, so that means that it's probably rounding issues that are causing the other ones to be wrong. And we can play, we can toy with it, but I don't like that. So I'm going to just toy with that first number. Yeah. So it looks like it has automatic errors in it. Always has to happen. So they probably have a strong positive, mostly between the path, price. So do we see any problems with multi-canary? Yes. So there's going to be a problem because, again, we're already running into them. So, yes. Use the statistical software package to determine the multiple regression equation for price and size. Okay. So, we're going to try to go ahead and solve everything else. And if y'all pop up that error, again, take a screenshot that those answers are coming out wrong, and then take a screenshot or send me your Excel that you did for that one. Because, yeah, that is messed up. Okay. So, again, taking our data, down analysis, regression, okay. And our Y is our price. And our X is going to be our size. Okay. Hit OK. Whoops. Looks like we had an error. Data. Here. Dallas analysis. OK. We do not have labels. Hit OK. Delete. All right. So, for us, this right down here is our regression equation when it comes to size. So, negative 18055.24. And size is 108.5794. Okay, guys. It seems like this problem is actually completely wrong. So I'm going to give y'all full credit for this one. Don't worry about doing this one. We're going to remove it. In fact, 9 and 10, I can already feel like 10 is going to do the same problems. So we're going to go ahead and just remove. Just do the first 8. If you've already done these, then by the time the video came out, then you're okay. So I will see y'all for question homework chapter 15. Yeah, I'm just going to go ahead and remove these two. Sorry about that, guys.